Okay, so the first thing I have to teach you is the concept of what means to be one-to-one and not one-to-one. So like before, when we had the vertical line test to see if something was a function or not, that we have something for a thing called one-to-one. So something that is one-to-one, one looks like this. So it really means, if I have a picture here, this function is one-to-one. This picture is one-to-one. If I have a graph that looks like this, and I draw like a parabola, this is not one-to-one. So if I can literally take a horizontal line and move it anywhere along my graph and I get exactly one value that touches that horizontal line, this basically ensures that my graph is one-to-one. If I take a horizontal line and I touch it and I can make it touch a spot where there are two possibilities, then guess what? This is not one-to-one. So the definition is this. For each number in what we call the range, so that's the y values of our function, basically they have exactly one value, and you check this with a horizontal line. That's it. You draw your picture, you show the horizontal line. If it touches two spots on our graph, it is not one-to-one. Okay, so now that we've come to that, I have a definition to tell you. So here is the rule. Let's just call this the rule for one-to-one. A function is one-to-one if and only if I find that f of x1 is equal to f of x2, then x1 must be x2. That's just the mathematical equivalence to what we were doing here, just using the horizontal line. So when we use a horizontal line here and here, if there was one value, if f of x was this, then the x values must be the same. That's all it is. So really what we're saying here is some crazy stuff. We're actually saying that if I have a function, f, it will be only one value. That's all it is, right? So today we're going to talk about a thing called the inverse function. All right. So here is a rule that you're going to use. And this is for inverse functions. We're going to eventually use inverse functions to go and find the range of something. So don't worry about it. We're just going to go through the math here and talk about it. So when we talk about inverse functions, this is what it is. So this is the rule. Let f be a one-to-one function. Let's go 1, 2, 1 function. With domain, so that's our x values, x, and range. Remember, our range represents the y values, and we'll call it y. And imagine if our little x is actually inside our big X. So x is some value inside our x function. inside our big domain. So it might be the real numbers. It might be some set of points that you said your function can work on. All right. Now imagine if this actually happened. If we have this specific thing come up, then this is amazing. F of F inverse of X is equal to X. So remember, we were talking about one-to-one. So imagine if I show you, if I go and make you calculate F inverse and F, two values, and then you stick one in the other and you get X back, then you know your function is one-to-one. So let's go and see if we can use this to our advantage. Okay, so now we have F of F inverse is equal to X. We also have one more thing we should say. And this is also true. And F inverse of F at X is equal to X as well. So those two things can happen. So if a function is one-to-one, like I talked to you up above, then we can actually do this. It's amazing. It is a function. All right. So now let's go and find a basic function. I'll show you how to do that. So here are the steps to find an inverse. Okay, I'm going to do it. I'm going to write out the steps, and then to the right of here, we're going to do a problem. Okay, 1. We start with interchange the X and the Y's. Okay, so imagine, find the inverse of F at X equaling, let's say 1 over 2x minus 3. The first thing that you have to do is you have to let y is equal to 1 over 2x minus 3. And then this blue part says we're going to interchange x and y. So we're going to let y equal x and x equal y. Okay, so now we've done step 1. Okay, so we've interchanged x and y. Stage 2, I'm going to put this in purple. Stage 2 is you solve for y. So you're just going to solve for y based on that equation that we had. So I'm just going to continue here. So we have x. So we have x is equal to 2y minus 3. So what we have to do is we have to do some sort of cross multiplication. So now I'm going to turn this into something over 1. And what I'm going to do is I'm just going to do a cross multiplication to kind of bring all these things together. So you're going to get 1 is equal to, well, x times 2y minus 3. And so you have 2xy minus 3x is equal to 1. Bring the x over to the other side, so you get 3x and 2xy and a plus 1 on that side. To get y by itself, we're going to have to divide everything by 2x. And guess what? There's our solution. Y is equal to 3x plus 1 over 2x. And this is what we call the inverse. So we've just done that. Okay. And stage 3 of our problem is going to be something really easy. So what we're going to do is, I'm just going to shrink this so everything is here. And stage 3 is this. Rename what we found for y to be f inverse of x. So f to the -1 of x. So f inverse of x is equal to 3x plus 1 divided by 2x. And we're done. And we're literally done our solution. So that would be the final step to actually find our basic equation. From here, I can ask you things like, please state the domain of f, and then the domain of, and the range of f. So what is crazy is, if I knew what the domain of f, you could easily calculate that back here. This one, we can calculate the domain of f, right? Now, if I asked you to look at this one here, I could ask you, hey, tell me what the domain of f inverse is. F inverse is that. Do you know what that actually tells me? It actually tells me that the range's domain is is y not equal to 0. It's kind of crazy. But right now I could say, tell me what the domain of f is, and tell me what the range of f is. Okay, so you know what we'll do? We'll go and do one more example on the next page with these two equations that we started with. So recall, before we found that fx was 1 over 2x minus 3, and we found f inverse is equal to 3x plus 1 over 2x, right? What if I asked you to find the domain and range of f and f inverse? F and f inverse. Okay? Let's do that. So for f, for the function f, the domain is equal to, well, simple. If you look at this, you know that x cannot equal 3/2. So x such that x cannot equal 3/2. Okay? So you kind of have to look at the domain, at the denominator of this function, and just check, right? And you can say, okay, it's not equal to 3/2, and x belongs to all real numbers. Okay, so that's for f, right? So now we'll just put like a little f to kind of represent that. Now, let's go and take a look at the range of f, the domain of, for let's say, f inverse. So you've got, you look at f inverse, and you can say that, in this case, x cannot equal 0. So when we say we have the domain of f inverse, it's just going to be x such that x is not equal to 0. X belongs to real numbers. Okay? Now, here's the best part about learning about the f inverse. If I want to find the range for f, if I found the inverse if I found the domain, the inverse, and then I can tell you what the domain of the inverse is, then that is the range. So the range of f is, instead of x, you're going to say y such that y is not equal to 0, y belonging to real numbers. Oh, wow. So basically this and this. So that's saying that this part, the range of f, comes directly from our inverse's domain. And then, if you think about it, the domain of the the range of the inverse is literally going to be all of the y values such that, oh boy, y is not equal to 3 over 2, where y belongs to all real numbers. Oh my goodness, that's insane, isn't it? So the domain of the regular function is the range of the inverse function, and the domain of the inverse function is the range of the inverse. And that's it, right? So you can use that to do your work. So if you ever need to find the range of a function, just go find its inverse. And then once you found its inverse, you know what its range is, what the original range is. Okay, so now let's take a look at this next problem here. Let's graph the function f of x is equal to negative of negative x for x less than 0, but then the square root of x for x being greater than 0, greater than or equal to 0. And what I want you to do now, I want you to determine, and you're going to determine if it's 1-to-1. Okay. So now let's do that. Here we go. We're going to graph our function. So imagine you have your function. This is a square root function. So a square root function would have, let's see, points of 1, 2, 3, 4. So I'm going to show you what the original square root function looks like. So the square root function starts at 0, 0. It goes over 1, and then when you square root 1, you're going to get this point here, 1, 1. When you go over 2, nothing, but when you go over 4, the square root of 4 is 2. So this part represents the square root of x. So that's y is equal to the square root of x. Okay? So now, if I want to graph, let's say I want to graph this. Let's put an aside here. Let's say I want to graph the square root of x, and we're going to turn it into negative square root negative x. We got to use the math that we did before. So the first thing that we do is we start with the square root of x. Now, to get to the negative root of x, that means we're going to flip our graph down. So the graph goes, it's reflected in the x-axis in x. So it's reflected in x. So our graph now looks like this. I'm going to put that in blue. So that's what our graph is as our transformation. Uh-oh. So our graph kind of looks like this. So now to get the negative x part, I'm going to use a different color. Let's say we use green. So we have negative root of x and there's a negative sign in here. So that negative sign says that the graph is flipped horizontally. So it's going to be reflected in the y-axis. So now our green values are going to be here. So now we have our points here and here. And our graph looks like this. So that's what our final graph looks like. So it is y is equal to negative square root of negative x. So, and determine. So we've graphed it, and we're going to determine if this is 1-to-1. So this blue graph here can be erased. We don't need it because that's not what our final graph looks like. So now, if you look at this line, if you look at this curve, and we draw horizontal lines, or take a ruler and move it up and down this entire thing, you'll notice that there's always at one point where the ruler would touch. So therefore, it's 1-to-1. F is 1-to-1. And you can say that this is because of the horizontal line test. So this is why you actually had to learn how to graph properly last time. So now this problem is asking you to prove that something is not 1-to-1, but you can't really graph it, right? So here's what I do. I actually cheat. So here's the deal. You go and graph the function 1-to-1. So you use the techniques. We use the techniques we studied before. X plus 10, it's going to look like this and this, right? So all we really need is one x value that gives us two possibilities. So let's just try it out. So I'm going to choose, say, the value of x equals 0 here. So I start with my equation and I go f of 0 is equal to, well, absolute value of 0 plus 10. Well, isn't that just 10? Okay, but guess what? You could also find that f of negative 20 is also equal to negative 10. Wait a second. Oh my goodness. So you're literally saying you have for the point, for x, for y being 10, you have two possible values of our x's giving out a 10. So you'd say, well, guess what? Because of the rule of being 1-to-1, well, look here, 0 is not equal to negative 20. So for the x's, 0 is not equal to 20, which means that f is not 1-to-1. i.e., when we took these 2 points going across here, for x is 0 and x is 20, sorry, negative 20, basically they're not the same number, so because of that it fails the horizontal line test. Okay. So for this problem, what we're going to do is find our inverse, like we stated before. So I'm going to do that for f of x. Start by letting y is equal to f of x, and then swap our x's. And now you're going to cross multiply. So now that you've got this next one, xy minus 2x equals 1 minus y, now we have to collect all the y's to the left side and put all our x's to the right. So now that we have xy plus y is equal to 2x plus 1, what we can do now is factor out a y from the left side to get this. So now you can divide both sides by x plus 1. And your final answer is y is equal to 2x plus 1 over x plus 1. So therefore, f inverse of x is equal to 2x plus 1 over x plus 1. And our original function is f of x is equal to, what was it, 1 minus x over x minus 2. Now, you can calculate the domain of f, and you can say that x such that x is not equal to 2. Stop there. Take a look at the range of f of the domain of f inverse. So d of f inverse is equal to x such that x is not equal to -1. And guess what? Our ranges for f is taken from here. So you get the range is y such that y is not equal to -1. And the domain of our inverse is just taken from the domain of f, which is equal to y such that y is not equal to not -1, but 2. And we're done. That's it. There's our answer. Woo! So here's your homework. It's page 104. You're going to do number 7, 9, 11, 13, 15, 17, 19, and 21, and 31. Oh, and don't forget 29. Those are the questions that we are doing for work today.